Our sun is a star, a giant ball of hot gas that illuminates and warms our world. Without the sun, life on Earth wouldn't exist. It's the gravitational anchor of our solar system, keeping everything from the largest planet to the smallest asteroid in its orbit. The sun provides the energy that drives our weather, fuels plant growth, and quite literally makes our planet habitable. Life on Earth has evolved over billions of years, perfectly adapted to the amount of light and heat received from the sun. But what if we swapped our familiar sun with the largest star known to exist? How would our solar system change, and what would become of our planet? In the vast expanse of the Milky Way galaxy, tucked away in the constellation Scutum, lies a star of truly gargantuan proportions, UY Scuti. This star is not just any star, it is a cosmic giant that has fascinated astronomers and stargazers alike. This red hypergiant star is the largest one we know, a pulsating behemoth with a radius estimated to be over 1,700 times larger than our Sun. Its sheer size and scale are almost beyond human comprehension, making it a true wonder of the universe. To put that in perspective, if UY Scuti were to replace our Sun, its outer layers would extend beyond the orbit of Jupiter, engulfing the first 4 planets: Mercury, Venus, Earth, and Mars. Imagine looking up at the sky and seeing a star so vast that it stretches across the entire horizon. It's a star so colossal that it dwarfs our Sun in size and luminosity, shining with the light of hundreds of thousands of suns. The energy it emits is staggering, illuminating its surroundings with an intensity that is hard to fathom. UY Scuti's sheer size is almost incomprehensible. It challenges our understanding of what a star can be and pushes the boundaries of astronomical knowledge. If we could somehow travel around its circumference at the speed of light, it would take us over 6 hours to complete one loop. This gives us a sense of just how vast this star truly is. Compare that to the Sun, which could be circled in a little over 14 seconds at light speed. The difference is astronomical, highlighting the immense scale of UY Scuti. The Sun, our own yellow dwarf star, is a powerhouse in its own right, providing the energy that sustains life on Earth and driving the climate and weather patterns we experience daily. But it pales in comparison to the behemoth that is UY Scuti, one of the largest known stars in the universe. Let's break down the differences between these two celestial giants to truly understand their scale and impact. Size. The Sun has a diameter of about 865,000 miles, which is already massive by any standard. UY Scuti's diameter? A mind-boggling 7.5 billion miles, making it over 1,000 times larger than our Sun. That's like comparing a basketball to a skyscraper, an almost unimaginable difference in scale. Luminosity, the Sun shines brightly, providing the light and warmth necessary for life on Earth. But UY Scuti is a cosmic beacon, outshining our Sun by a significant margin. It emits over 340,000 times more energy than our Sun, a staggering amount of power, making it one of the most luminous stars in the Milky Way, a true giant in every sense. Temperature. While the Sun's surface temperature is around 10,000 degrees Fahrenheit, scorching by any measure, UY Scuti is much cooler in comparison, with a surface temperature of about 6,000 degrees Fahrenheit, which is typical for red supergiants. This cooler temperature is characteristic of red supergiants. These differences are staggering, highlighting the diversity and scale of stars in our universe. And they highlight the immense scale and power of the universe's largest stars, reminding us of the vastness of space. But what would happen to our little corner of the cosmos if we swapped our Sun for this supergiant? The consequences would be dramatic and far-reaching, altering the very fabric of our solar system. The moment UY Scuti replaced our Sun, an unimaginable transformation would begin. The solar system's delicate gravitational balance would be thrown into disarray, causing chaos among the celestial bodies. The massive increase in gravitational pull would have immediate and catastrophic consequences, altering the very fabric of our cosmic neighborhood. The inner planets, including Earth, would be pulled inwards towards the colossal star, their fates sealed by the overwhelming gravitational force. Their orbits would be drastically altered, no longer the familiar elliptical paths we know, but chaotic and unpredictable trajectories. Some planets might even be completely ejected from the solar system, flung into the void of interstellar space, lost forever in the vastness of the cosmos. The outer gas giants, Jupiter, Saturn, Uranus and Neptune, would also experience significant changes in their orbits, their stability shattered. While they might not be swallowed up by UY Scuti, their orbits would become highly elliptical and unstable, leading to unpredictable movements. The asteroid belt, a region populated by millions of rocky bodies, would be scattered and disrupted, its structure irreparably damaged. Some asteroids would be hurled inward towards the inner solar system, posing a significant threat to any surviving planets, potentially leading to catastrophic collisions. Section 5. Scorched Earth Immediate Consequences. For Earth, the consequences of this stellar swap would be nothing short of apocalyptic. The moment UY Scuti replaced the Sun, our planet would be bathed in intense heat and radiation. The Earth's surface temperature would skyrocket, vaporizing oceans, melting mountains, and incinerating anything that couldn't withstand the unimaginable heat. Life as we know it would be extinguished in an instant. The sky would be ablaze with a reddish-orange light, vastly different from the familiar yellow glow of our Sun. The night sky, as we know it, would cease to exist, as the massive star would illuminate the entire solar system in a perpetual twilight. Section 6. Beyond inhabitability long-term effects. Even if Earth was somehow spared immediate incineration, its long-term prospects would be bleak. UY Scuti, despite its immense size, is nearing the end of its life cycle. As a red supergiant, it's a star on the verge of a supernova, a cataclysmic explosion that would release unimaginable amounts of energy. When UY Scuti goes supernova, it would likely obliterate any remnants of our solar system within a vast radius. The supernova would be visible from Earth, if it still existed, as a blinding flash of light, brighter than a full moon, and potentially visible even during the day. It would be a cosmic spectacle marking the end of an era for our solar system. Section 7. The Sun's vital importance. This thought experiment, while purely hypothetical, underscores the crucial role our Sun plays in the existence of life as we know it. It's easy to take the Sun for granted, but its size, temperature, and energy output are perfectly calibrated for life to thrive on Earth. Our Sun is a remarkably stable star, providing a consistent source of energy that has allowed life to evolve and flourish on our planet for billions of years. This stability is something we wouldn't find in a star like UY Scuti. The Sun is our life giver, and its continued presence is essential for the well-being of our planet and every living thing on it. Section 8. Conclusion: a universe of wonder. The universe is full of wonders, from stars like our Sun to colossal giants like UY Scuti. By imagining our solar system with the largest known star at its center, we gain a deeper appreciation for the delicate balance that makes our existence possible. It's a reminder of the vastness of space, the incredible variety of celestial objects it holds, and the preciousness of our own place in the cosmos. The universe is a place of constant discovery, and there's always something new to learn about the cosmos and our place within it. Section 9. Join the cosmic journey. Do you want to explore the universe further? Subscribe to our channel for more mind-blowing content about space, stars, and everything beyond.